Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at triangular and trapezoidal prisms. We previously looked at rectangular prisms and found their surface area and volume. We'll do the same for general prisms here. So here we have a triangular prism and a trapezoidal prism. So remember, a prism is a solid with a consistent cross section. This is a prism because the front and the back are the same shape, same size. Here, this is a prism. The cross section that's consistent is a triangle. So the volume of any prism is nice and easy. It's AH. It's area of the base times the height. So for this triangular prism here, we first calculate the area of the base. Now, sometimes that's not going to be easy. Here we're going to need to use Pythagoras to calculate the area of the triangle. It is an equilateral triangle with side length 6 centimeters, but we need the perpendicular height. So calling the perpendicular height, I'll just call it K here. We can use Pythagoras because this side will be 3, this side will be 6. So the perpendicular height of this triangle will be square root of 6 squared minus 3 squared. And the exact value there is root 27. That is the perpendicular height of the triangle. So the area of the base is going to be base times perpendicular height divided by 2. So putting that in our calculator, we get about 15.5885 centimeters squared. Now I use 4 decimal places here because I need to use this in a subsequent calculation. To find the volume, I need to take this number and multiply by 15. So this can get a bit confusing. Volume equals area times perpendicular height. Here we mean the height of the prism, or the dimension of the prism that is perpendicular to the cross section. So here the height of the prism is 15. It does get confusing because this triangle also has a perpendicular height. That's what we mean here. You take the area of the base and times by the dimension that is perpendicular to the base. So the volume here, I take my area of the base and I just multiply it by 15. And I get around 233.8. So volume is always in cubic units, so it will be centimeters cubed. That also means it'll hold about 234 milliliters of liquid. So let's now calculate the volume of this prism here. It does look different, but for any prism, volume equals area of base times perpendicular height. So the area here of the base, the area of the trapezium, is h over 2 multiplied by the sum of the 2 parallel sides. So 20 by 4 gives us 80 meters squared. That's the area of the base. So to find the volume, we take area of base, we multiply by the height of the prism, and our answer is in units cubed. So this is 800 meters cubed. That means it would hold 800,000 liters of liquid. And it makes sense that it would hold heaps of liquid because this is a massive container. As I said, this would be bigger than a lot of buildings. All right, that's all well and good for area. Now we're going to calculate the surface area of each of these shapes. So please pause and copy this down if you need. So we're not going to use a formula to find the surface area of each of these two shapes because it can make things quite complicated. For a triangular prism, if you wanted a formula for its surface area, you'd have to have a different formula for when this was equilateral, when it was isosceles, when it was scalene. It's just too hard. It's much easier just to understand that the surface area of any solid is just the area of each of its exposed faces all added up. So we're just going to do that here. We're just going to find the area of each face and add it up. So note here, I'm assuming that both of these are closed. They have all their faces. Of course, if you take one face away, if you open up the shape, the surface area changes even though the volume doesn't. So let's find the surface area of this shape here. Well, we need to find the area of these two triangles. We actually did that before. We found that the area of each triangle was about 15.5885. So I use 4 decimal places because I'm using that number in a calculation. So I already calculated the area here. Now I'm timesing it by 2 because there are 2 triangles there. In addition to the 2 triangles, a triangular prism also has 3 rectangles. Now you have to be careful here. Sometimes those 3 rectangles will have the same area. Sometimes they'll all be different. Depends on the type of triangle you have here. Because this is equilateral, each of these 1, 2, and 3 at the bottom rectangles will have the same area of 15 times 6. So I can just add to that 15 times 6 times 3. But if this were not an equilateral triangle, then these 3 rectangles would have different areas. So putting this on our calculator, we get about 301.2, and area is always in square units. All right, let's look at the surface area of this shape here. So we have a trapezium at the front and the back, and trapezoidal prisms, they also have 4 rectangles. So we already figured out the area of the trapeziums was 80. So area of trapezium at the front and the back is 80. We do 2 times 80 because there are 2 of them. So now what we need to do is need to add the area of the 4 rectangles. So there's a rectangle here at the side that is 8 by 10. There is a rectangle at the top here that is 7 by 10. There's a rectangle at the bottom that is 13 by 10. So that's 3 of the 4 rectangles, but I haven't done this one here. So to do this one here, I need to know the slant height of the trapezium. So to do that, I'm actually going to need Pythagoras again. So I know this side here is 8. This side here is 13 minus 7, which is 6. So using Pythagoras, this length here will be the square root of 8 squared plus 6 squared, which is 10. So this slant height is 10, so this last rectangle I needed will be 10 by 10. So we have just added up the area of the 2 trapeziums and the area of the 4 rectangles. So putting that on the calculator, we get exactly 540, and this will be meters squared, and we're done. All right, let's now look at a harder problem. So here we're told to calculate the volume if the surface area is 1392 units squared. So if we want to calculate the volume, we need the area of the triangle, and we need to multiply by this, the height of the prism, perpendicular height of the prism. So our first question should be, okay, what do we need to do to find the volume? We need to find h. So let's use this information to find h. So we're going to use that the surface area is 1392 to find h. So what would be the surface area of this prism here? Well, it would have 2 triangles, each of which is 16 by 12 over 2. So that's the 2 triangles, and then it would have 3 rectangles. So the bottom rectangle here is 12 by h. The rectangle at the back here is 16 by h. But what about this top rectangle here? What would be its measurement? We can figure that out easily. Again, using Pythagoras, this side here is just the square root of 16 squared plus 12 squared is 20. So the area of this rectangle here is 20 by h. We're told that all up, that gives 1392. Now, this might look like quite a complicated equation, but it's really not. We just have here 192, the area of the 2 triangles combined, plus so 12 plus 16 plus 20 is 48. So 192 plus 48 is 1392. So we subtract 192 from both sides. We divide each side by 48. We get h is equal to 25. So now we found that finding the volume is easy. The volume is just the area of the base, and we figured out area of the base is 16 by 12 over 2. Area of the base, area of the triangle, times the perpendicular height. So it's 96 times 25, which is 2,400 units cubed. and then we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.